Hello everyone, I'm Mohammed and today I'm going to talk about guided co-modulated GAN for 360-degree field of view extrapolation. Imagine we have this 2D image and we want to make it way cooler by rendering a shiny spaceship on it. Take a closer look at the spaceship and notice how it is reflecting the entire scene, not just the background visible in the image. Conventional cameras capture a small fraction of a scene because they have a limited field of view. So this is what the camera observed, but this is what we need, the entire 360-degree field of view of the entire scene. In this work, we develop a model based on generative adversarial networks called GAN to address this problem. Our method is based on Co-Modulated. We apply some modification to make it suitable for field of view extrapolation. First, we use field of view masks that are generated using conventional camera parameters. Next, we change the architecture of each block to work with 2x1 panoramas. Finally, we roll the output of the generator before feeding it to the discriminator to remove any boundary around vertical edges. The main limitation of this architecture is that you cannot modify the generated output without modifying the input. Therefore, we introduce a new mechanism to incorporate semantic information into the generation process. First, we remove the link between the encoder and the learner-affine transform. Next, we use a pre-trained scene classifier as the guide network, and then we feed the features of the guide network to the learner-affine transform. We can have the corresponding classes that represent the input by feeding the features to a classification layer. By modifying the labels and doing backpropagation for one layer, we can change the output. Our method can generate high-resolution detailed panoramas. We can also change the generated content to represent picnic area and a snowfield as some example. Using our method, we can generate rendering with realistic reflections for shiny objects. Thanks a lot for your attention, and please check out the website of our paper for more results.